This video is about datagram switching, which is a typical way of packet switching. Instead of packets, it is common to refer to datagrams when talking about the data units. In datagram switching, datagrams traverse the network independent from each other. This means that on each intermediate system, a new decision is taken on how to forward the datagram. As you can see in the drawing, this implies that the datagrams can take different paths so that the order of the datagrams may not be preserved. In the example on the slide, the green datagram overtakes the yellow and blue datagram. On the next slides, we discuss advantages and disadvantages. This discussion has to be regarded in the context of the overall packet switching pros and cons. Advantages of this method are that it is relatively easy to implement. Intermediate systems work in a stateless manner so that they do not have to remember the routing decisions which they have taken before. The method is robust against failures of links or intermediate systems. In such a case, the next datagrams are routed to another router so that they can bypass problems in the network. Since the whole method is not connection-oriented, there are no efforts for connection establishment and decommissioning, so that transmissions can start immediately. In the Internet, this is beneficial because often only short-lived communications are observed. Disadvantages of this method are that the order of datagrams may not be preserved, as we have seen on the first slide. In addition, complete addressing information has to be contained in the datagrams so that the routing decisions can be made. Such an overhead implies that less address space is available for the payload. Datagram switching is a basic principle used in the Internet. That is how the Internet protocol works.